Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the concept of ESR flip-flop. So previously we had discussed what is a flip-flop as well as a latch. A difference between a flip-flop and a latch is the latches are not using a clock signal, whether a flip-flops are using a clock signal in according to enable the output. So firstly, we are considering the concept of ESR flip-flop. Here, in an SR flip-flop, we can see that we had designed this flip-flop with the help of Nand gate. Here we can see 4 different Nand gate combinations, and the input of first set of Nand gate is provided with a clock signal. Simply, this clock signal enables the output depending upon the input of clock equal to 1. So while analyzing this SR flip-flop, we can see that the second set of Nand gate is the SR latch itself. So the output of the SR flip-flop is completely depending upon the SR latch concept. So my dear students, the concept of SR latch is very important. So before going to this SR flip-flop concept, previously we had discussed the SR latch. Kindly go through this SR latch concept. So now we are going to our concept terminologies. So just refresh the SR latch concept. So the SR latch using Nand gate is as follows, and here we can see that 2 Nand gates are used to design the SR latch concept, and the first Nand gate's output is given as 1 input to the second Nand gate, and second Nand gate output is feeding as 1 input towards the first Nand gate. And S stand for set as well as R stand for reset, and Q represents the output signal. And the truth table of SR latch using Nand gate is as follows: S equal to 0, R is equal to 0 result in a invalid condition, thus this is not using in a Nand gate concept. The S equal to 0, R equal to 1 results in an output of 1. S equal to 1, R equal to 0 results in an output of 0, as well as S equal to R equal to 1 is known as a memory condition, that is, it is preserving the previous value. So my dear students, if we are dealing with a Nand gate, if any of the input value is 0, then the output will be 1. If all the inputs are present, that is, if all the input are 1, then the output will be 0. This is the simple Nand gate combination. So my dear students, now let us discuss the SR flip-flop. Here, the first Nand gate, that is a yellow Nand gate, is provided with an input of clock as well as a set signal, and the second Nand gate, that is a green Nand gate, is provided with an input signal of clock as well as reset signal. The output of the first Nand gate, that is yellow Nand gate's output, is represented as S star, and the second Nand gate, that is a green Nand gate's output, is represented as R star. So here from this figure we can explain that S star is the combination of S dot clock the whole complement, that is, the input of the Nand gate number 1, yellow Nand gate, is S and clock, thus the output will be S dot clock signal the whole complement. Since we are dealing with a Nand gate, we are taking the complement, so S dot clock complement can be expanded as S complement plus clock complement according to the De Morgan's law. Similarly, the R star can be represented as R dot clock complement, which is equal to R complement plus clock complement according to De Morgan's law. So now we are discussing the working of SR flip-flop. So here, while analyzing the SR flip-flop, we can see that the second set is the SR latch concept itself. So now we are starting with the clock signal equal to 0. So if the clock signal is equal to 0, the different combinations of S and R will be 0, 0, 0, 1, 1, 0 and 1, 1. So simply we are discussing the clock signal as 0. Then the expression S star will be S complement plus clock complement. Here the clock signal is 0, thus S star is equal to S complement plus 0 complement. 0 complement is 1, Therefore, S complement plus 1 will be S star. Any value is ORing with 1 results in an output of 1. Thus, S star will be 1 if we are providing a clock signal of 0. Similarly, R star can also be represented as R star is equal to R complement plus clock complement, R star is equal to R complement plus 0 complement, that is equal to R complement plus 1. Simply R star is equal to 1 itself. Now let us consider the SR latch concept of S equal to R equal to 1 condition. So here the second set of circuit is the SR latch itself with S value equal to 1, R value is equal to 1. So if we are analyzing the truth table of SR latch, S equal to 1, R equal to 1 results in the memory condition. This simply means that the clock signal with 0 and S equal to 0, R equal to 0, S equal to 0, R equal to 1, S equal to 1, R equal to 0, S equal to 1, R equal to 1 results in the memory condition itself. Thus, we can conclude that if the clock is 0, then the output is completely dependent upon the previous output itself, that is the previous output itself will be preserved. Thus, the clock equal to 0 results in the memory condition. So now we are discussing the clock signal equal to 1 condition. So if the clock is equal to 1, then the different conditions will be S star becomes S complement plus clock complement, that's equal to S complement plus 1 complement. Here clock signal is 1, thus we are taking the complement of 1, which will result in 0. Thus S star is equal to S complement plus 0. Any value plus 0 is that value itself, that is S star is equal to S complement. Similarly, R star is equal to R complement. That is, if we are providing a clock signal as 1, then S star will be S complement and R star will be R complement. So firstly, we are starting with the input of S equal to 0 and R is equal to 0. Then the output of these two NAND gates, that is the S star and R star, will now becomes 1 and 1. So now we have to check the truth table of the SR latch with input 1 and 1. So this 1 and 1, S star is equal to 1, R star is equal to 1, will result in a condition of memory. Thus we can tell that if clock is equal to 1, S is equal to 0, R is equal to 0, results in memory condition. So now we are moving to the third condition, that is clock is equal to 1 as well as S equal to 0, R is equal to 1 condition. So S is equal to 0 results in S star is equal to 1 and R is equal to 1 results in R star is equal to 0. So now we have to check the truth table of SR latch with S equal to 1, R is equal to 0. S equal to 1, R is equal to 0 results in an output of 0, that is Q value becomes 0. So the truth table of SR flip-flop with clock is equal to 1, S equal to 0, R is equal to 1 will be 0 condition. So now we are moving towards the fourth condition, that is clock is equal to 1, S is equal to 1 and R is equal to 0. S is equal to 1 results in S star is equal to 0. R is equal to 0 results in R star is equal to 1. So now we have to check the truth table of SR latch with S equal to 0, R is equal to 1. So S equal to 0, R is equal to 1 results in an output of 1. Thus, the SR flip-flop with clock is equal to 1, S is equal to 1 and R is equal to 0 results in an output of 1. So now we are moving to the last condition, that is clock is equal to 1 and S equal to 1 as well as R is equal to 1 condition. Here S equal to 1 results in a condition of S star is equal to 0. R is equal to 1 results in R star is equal to 0. Thus, if we are analyzing the truth table of SR latch with S equal to 0, R is equal to 0 result in a not used or invalid condition. Thus, the SR flip-flop's output will be not used or invalid condition. So my dear students, this is how the ESR flip-flop is designed. And if we are consolidating the discussed terms, a clock signal 0 will result in the memory condition, and the clock signal 1 results in 4 different conditions with 0 0, that is S equal to 0, R is equal to 0 results in a memory condition, clock equal to 1 and S equal to 0, R equal to 1 results in a output of 0, that is the value will be reset, and S equal to 1, R is equal to 0 results in an output of 1, that is a set condition, and 1 1 condition, that is S equal to 1, R is equal to 1 will be an invalid condition. So this condition is not using in an SR flip-flop. And my dear students, and this is a symbolic representation of SR flip-flop. Here we can see 5 different pins. 2 pins deals with the input and 2 pins are for output and 1 pin is for clock. If you are considering the input pins, those input pins are set pin and a reset pin, and the label is S and R, and the clock pin deals with the clock signal, and the output pins are Q and Q complement, that is output as well as complement of the output. So my dear students, this is the symbolic representation of SR flip-flop. So my dear students, hope you had understood this topic. So dear students, based upon this truth table, in the upcoming lecture we will discuss the characteristic table as well as the excitation table of this SR flip-flop. So dear students, kindly go through this assignment question. Question is, write notes on SR flip-flop. So dear students, as we mentioned, in the upcoming lecture we will discuss the characteristic table as well as the excitation table of SR flip-flop. So dear students, see you soon. Until then, goodbye, thank you, and all the best.